Do you want to check out ITProTV but aren't ready to commit? We're making a few episodes from our most popular courses free for you to try here on YouTube so you can see what they're all about. Enjoy this episode and head over to itpro.tv when you're ready to see the full course.
That's right, networking is a wide world of different technologies that we have to take a look at. But where should we begin? Well, we're going to begin with a networking model called the OSI model. Find out why next.
You're watching ITProTV.
All right, the OSI model is one of those models we absolutely will have to learn not only for the exam, but it's something that Wes and I have actually used every day. Wes, why is this a good place for us to begin?
Well, it all boils down to interoperability, right? In the earlier days of networking communications, we had all these different vendors swearing by their products, and if I use a certain vendor, I'd have to stick with that vendor. And the problem is, if you had a network that had a different vendor, well, guess what? We're not going to be able to communicate together. So one of the big things about what's known as the Open Systems Interconnection Model is the fact that it brings a layered approach to networking functions, and what it does is it allows us to standardize network communications. Now, it's important to understand that the OSI model was invented, if you will, by a consortium, a group of a bunch of companies and a bunch of countries to standardize that communication, and that's the International Organization of Standardization. And what it provides is a layered framework for describing network functions.
Yeah, it's kind of interesting here, just as a little side note. You'll never see it actually written, except on Wes's slide here, International Organization for Standardization. A lot of times you hear the term ISO written in all capital I-S-N-O. You'll hear ISO standards and different things. That's the same organization. But ISO itself, as you see, the order is actually out of order there. And it's because instead of actually having it as an acronym, they chose the idea here of actually saying, we want a word that represents it to be equal between all these different companies and countries in terms of the way that this is going to go about. So they chose the Greek word ISO to represent equality in that sense too. So Wes, again, let's kind of dive into that idea, that layered approach, just a little bit more. Now, when we start talking about it from the standpoint of the way that it was, okay, that meant that a single vendor could actually develop their own networking however they chose to do it.
That's right.
But with the layered approach, how does that help in terms of interoperability?
Well, it standardizes the communication approach between networks in a way that if you follow it, what's going to happen is Ronnie's devices will be able to communicate with my devices and back and forth. It's all about that consistency, that consistent interoperability, and that's one of the reasons we like the standardization. Now, you mentioned that layered approach, all right, the layers, if you will. There's a couple of different ways that you can think about these layers when they're defined. You can think about them from top to bottom, or you can think about them from bottom to top. Ronnie, I was thinking for our discussion purposes here, what we would do is we would start at the top of what they call the stack or the layered approach, and we would work our way down.
Sounds great. So, Wes, when we start at the top of this model, why are we choosing to start at the top?
Well, the reason I've got it set up this way is because I want to define really quickly just how these blocks, these layers, if you will, are grouped together, and what is it that they're actually doing together with each other. Let me show you what I mean here. So you're going to notice that I got a little bit of a color coding going on here, and I've got 3 layers at the top, and they're all similar. 4 layers at the bottom, they're all similar, all right? Now, why is that? Well, that's because I'm breaking these up into the upper layers and lower layers based on their functionality, if you will. The upper layers are application support functionality. They're what allow us to prepare the information to make its way onto the network, all right? And some of the functionality that you see here that we're going to talk about a little bit more. Again, formatting, encryption, decryption, if you will, things like session establishment, all happens at these upper layers. Now, the bottom layers, if you will, the lower layers, right, they support the network functionality. By the time our information gets within these layers that we're sending from source to destination, it shouldn't have to worry about the format, the syntax of the information. It just needs to focus on the end-to-end communication and make the decisions on how to get that information over to the endpoint. Again, showing you some of the different functionalities that we'll get into a little bit deeper here in a bit. things like addressing, if you will, making decisions where this data came in, where it's supposed to go out. Are we using radiated energy? Are we using bounded media? Are we using copper? Are we using electrical signals, optical signals? All of that is determined, if you will, by these lower layers that are supporting the network functionality.
Yeah, this is actually great because it really does help us to understand, like, why are these layers grouped the way that they are and why they actually sit the way that they are as well. So remember that the upper layers really do help us to prepare the data for the network. And you might be wondering, like, well, what does that even mean? Well, remember that data that exists that we want to send on network is not ready to go on the network. So those upper layers help us to do that. Then that lower layer, right, once we get the data ready for the network, it ensures that the data can go from the source address to the destination. In other words, that we can get it from the beginning to the end. And that's why it's all important that we make sure that we understand at least the beginnings of this model. We're probably not getting as super into it as we would normally do, but you'll see that over time that you'll be working in it just about every single day if you're actually doing what you're actually doing on a network. Because we use it, Wes, how many times do we actually end up addressing the OSI model?
Oh my goodness, for troubleshooting,
Yeah.
and that's why it is important. You will see some people that'll say, "Oh, it's all theory," but when things go wrong, well, where is it going wrong?
This is
and
what
being able to identify those layers is going to help you for troubleshooting as well. So, Ronnie, I said that we're going to use the top-down approach. What do you say we go ahead and we'll jump into that very first layer?
Great.
All right, so going from the top of the stack, right, and that's from the top of layers down, right, you're going to see that they're numbered 7 to 1. If you say a bottom-up approach down here at the bottom layer, you're going to talk about layer 1 and go back up to layer 7. We're doing a top-down approach, all right? So the top-down approach, we're going to start at the application layer. And the application layer, its sole purpose is to give the application and your data that you're using access to the network. All right, now I'm going to mention a couple of protocols here. Actually, I'm just going to put them up on the screen. We're not going to really dive into them too much because we will later on. And I want you to be able to turn around. This is the OSI reference model. I want you to be able to reference the model later after we do talk about these protocols so you can see how they fit in the ecosphere of networking communications. So that's what's happening at layer 7, providing that application access to the network. And it's interesting, Ronnie, because this is also the only layer, if you will, that the user directly interacts with.
Yeah, now this is key. Let's go ahead and also use analogy as we go through to help us out here.
Sure.
So I like going back to the snail mail analogy that I've always used to help us out. Remember that the data that you actually have, if I wanted to send a regular letter over to Wes, let's say he is on the West Coast and I'm over here on the East Coast.
Sure.
Well, I can think about what I want to write to Wes, but that doesn't mean it's ready to be delivered across the United States postal system.
That's right.
So the first thing I have to have in that is an application. Now that application at the very basis, right, if we're sending a snail mail, is paper and pen. That is what now allows me to put down my thoughts on the paper that then can be delivered across that postal system. So that's where that application layer comes in. Now, there's a lot more into it, but let's just start right there, which actually leads us to the next layer.
I love the snail mail analogy. So we're going to stick with that. Great idea, Ronnie. So let's go ahead and let's get into what Ronnie said. Let's get into the next layer. The next layer is the presentation layer, all right, layer 6. And I should have mentioned that, and I apologize ahead of time not for mentioning that, or for not mentioning that, I should say. I've got the numbers there, layer 7, layer 6, also with whatever their name is too. Now, the presentation layer is all about format. I'm going to let Ronnie continue along with the analogy. I really like that. So formatting, syntax, right? Think about we want our information to be placed on that network, but it has to be in the proper format to allow that to happen. And again, we just kind of show you ahead of time some of the functionalities and some of the technologies that operate at this layer so that you can always reference back. So, Ronnie, I'll ask you a question. Where does our snail mail analogy, do you believe, fit in when we talk about the presentation layer?
Yeah, when it comes down to the presentation layer, for us to be able to put that down on network, we need to not just put that piece of paper into a mailbox and go, hopefully it gets to Wes. We need now fold it, right? That's where that presentation, that formatting comes in, right? I'll do a trifold. Then I need to put it inside an envelope. Once again, formatting that will work on the United States Postal Service network as well. Now, that can also include, when it comes to formatting, right, a stamp that's on it, and also properly where the source address and the destination address goes on the envelope. So we can actually put that on there at the presentation layer as well. We're actually just putting things in the right place so that when it gets on network, that system, that United States Postal Service employee can actually take a look at it, the machines can take a look at it, it can all function so it can get from source to the destination. So the presentation is a very important part of networking in postal and snail mail, as well as the networking itself.
Definitely. So if we continue down the stack, that's going to bring us to the next layer. And what is the next layer? Layer 5 here is what's known as the session layer. And when we talk about the session layer, now what we're talking about, think about it in the name, it's session establishment, right? I know that I need to send a communication from source to destination. Well, I need to reach out and I need to let that source know, hey, let's establish this communication, right? The session layer is doing that. But not only establishing that communication, let's monitor it and maintain it. All right, let's define the parameters of it before we even establish it. And then once it's established, let's monitor and maintain it. And then once it's no longer needed, well, let's go ahead and terminate the connection, right? Let's give those resources back to the operating system so they can use it for other tasks, right? Some of the things that we see within this realm, some of these technologies are things like NetBIOS, remote procedure call, server message block, and things like sockets as well, which we'll talk a little bit more about as we progress through our Network Plus training.
Yeah, when it comes to the session layer, this is something that we really don't have to handle when it comes to the United States Postal Service, because what we're doing is when we actually get everything ready, whether the stamp and everything is actually ready to go, we establish a session by putting in one of those little blue mailboxes or going outside to our own mailbox and putting up the little flag. The reason why we don't have to monitor it is because, well, the United States Postal Service is actually doing the monitoring and saying, hey, I'm going to try and get it from one end to the other one here. And we don't have to worry about fixing the network. We don't have to worry about anything else. We're putting it on their network service so they can have it. So we established that particular session by simply saying, I'm going to mail this and making sure it gets onto that particular system. So that's what we would do here.
Definitely. Now, once we're done with the presentation layer, we just keep moving down the stack, right? So the next one is going to be what's known as the transport layer, and this is layer 4. Now, transport layer, all right, I want you to think about this is the vehicle, right? This is the conduit that actually, we're going to make some decisions here on how are we going to get that information across the wire. It doesn't have to be the wire. I mean it figuratively for the network. It could be wireless, right? And we have two choices. The two choices that we have are the transmission control protocol and the user datagram protocol. These are the two primary transport protocols that we have today in networks, all right? And there's a couple of options, all right? When we talk about the transmission control protocol, all right, what we're talking about is connection oriented. When we talk about the user datagram protocol, we're talking about the exact opposite, connectionless, all right? Now, what does that mean? And I'm going to kind of steal a little bit of Ronnie's thunder here, but this is like now with his analogy of the snail mail, this is, do we need delivery confirmation? If I send that information over to Ronnie, do I want to monitor it and maintain it? All right, and make sure that it's received in the appropriate order. If it's too big, if the package is too big, do I want to turn around and put it into individual little boxes and then make sure that I number them and send those boxes, if you will, the data in smaller chunks, data measurement units, if you will, over to Ronnie? And then if we're missing one, my computer, or actually Ronnie's computer, is going to call back through TCP and say, hey, we're missing something. You need to resend that. So it makes sure that it's built in the right order as well. UDP, it doesn't ask for delivery confirmation. This is like finding one of those little blue mailboxes, and or even your own mailbox. You walk out, you put it in the mailbox, and you walk away, and you just hope it makes its way to the out there on the carrier's network. So the thing I want you to think about is that little term I said about breaking your data down and putting it into these smaller boxes and then numbering each one of the boxes. That's what's called sequencing and segmentation. All right. UDP, it doesn't have that. It does not do any of that, right? You just throw it in the mail and you walk away from it. And that's why we say one is reliable delivery, connection-oriented reliable delivery versus a connectionless, well, I hope it gets there, best effort delivery. So what do you think, Ronnie, as far as like our mail, our snail mail analogy here?
Sure, yeah, that actually works. The idea of TCP, though, is actually kind of, we probably actually do this more than we think as well, even on a slower system. But if you have an Amazon delivery and you buy 4 or 5 different packages, right? Sometimes it might come in a single box, but a lot of times it might come across multiple boxes. Well, if all that's part of one delivery, that's TCP actually breaking up, saying, hey, I can't put this all in one box. I need to break it up, but it still needs to get to the same address, same order and everything. So it can actually do that. Whereas the UDP is more like what you said, that traditional mail drop off. And you just go, all right, it's there. The network should get it there, and it normally does. And so you actually are dependent upon the other end actually getting it just because you trust the network's been set up correctly.
Definitely. So now that we've defined how we need to get it there, Now we need to start making decisions. Where do we send this, right? Now, Ronnie mentioned that during that presentation of, making sure that our envelope is addressed right, what do we have? We have to put a source and destination address. Now, once that source and destination address is, we now need to figure out how do we get that information to the destination. Remember, we're in the network functionality block here, and that's where the next layer comes in. The next layer is what's known as the network layer. All right, and the network layer is responsible for doing things like routing. All right, at a high level, that's, hey, I see the destination, I'm looking at a database, and according to this database, if I want to get it to this destination, I need to send it here. And then it goes to the next device, and the next device makes that same kind of thought process, if you will, or calculation, finally till it gets to the destination network where that endpoint actually is. Logical addressing, this is where we put software-based addresses that Ronnie's going to tell us about later in the series, right? This is where the routing protocols work at, our addressing protocol, Internet Protocol, IP. And we'll talk about things like ICMP and network address translation and some of the routing protocols as well. But that's what's happening here at the network layer.
Yeah, this network layer is probably the most important layer because it's how the entire postal system ends up working. It knows where to deliver every single piece of mail because we have that source and we have that destination, and it should be properly formatted like we talked about in the presentation layer. So once we actually have all that, then every device along the way, it gets put onto the right transport device that it needs to. It gets routed to the right postal system. It gets put onto the right carrier that ultimately gets to your mailbox. And that's why this particular layer itself is so important, that we actually are using a consistent protocol. For us on networking, that's going to be TCP/IP, or actually technically IP itself, is the addressing that we're actually taking a look at. So it's the same thing when we talk about the idea of delivering any type of piece of mail as well.
And one of the great things that I love how you say how important this layer is because when we say these networks, I don't have to be connected to Ronnie's network to actually get it to the endpoint. That's one of the beauties of the networking layer. Now, what do we use once we're inside of that network? How do we get that information? Now that we've made it to Ronnie, we know that the information's going to Ronnie's destination network. Well, now we're in the network. What do we use? What kind of technologies? And that's where this next layer comes in. The next layer is what's known as the data link layer, layer 2. And I want you to think about it inside of your local networks, and we'll define what that means coming up. All right, now we have a series of directly connected devices, and we still need to make decisions, right? Because not every device on that local network is going to be the destination. So this is what the data link data link layer, if you will, is responsible for. Flow control, things like acknowledgments, things like error detection, if you will. Now, what's interesting is that it also defines and determines access to the media, all right? And we're going to talk about that coming up because there are a couple of different choices that could be made depending on what technologies you use. But regardless of what technology you use, it's happening right here. See the consistency, that interoperability that we're talking about? Now, this layer is actually kind of interesting because it's actually broken up into a couple of sub-layers. There's one that is known as the Logical Link Control, the LLC, and we'll talk a little bit more about that coming up in some later episodes. And then the Media Access Control layer. And the way they're stacked here is that the Logical Link Control layer is actually communicating with the upper layer, all right? The media access control is actually connected to the bottom layer here. So just remember, once we've got that information inside that destination network, this layer helps us do the final delivery, if you will, to the endpoint.
Yeah, this is where it gets a little bit tricky because with the IP addressing itself, we know how it can get across the network. With the data link layer, this is how we know we can deliver it to that physical mailbox itself, because it has the address on the outside. That is what we call that layer as well. So we line up that logical address that was used across the entire network, and then ultimately it gets handed to a carrier, and the carrier knows exactly where it ends up going.
Definitely. And Ronnie, I didn't mention some of the technologies here, so we'll just briefly show you some of the technologies. Ethernet, the Autonomous Transfer Mode, ATM, MPLS, we'll talk about a little bit more later, point-to-point protocol, and things like Spanning Tree Protocol all happen within that data link layer. Now, Once that's done, we've got the last layer up, the bottom of the stack, right? And that's what's known as the physical layer. And the physical layer is where we are determining the electrical and mechanical characteristics. Are we using copper media? If we're using copper media, what's the length of the copper media? What's the transmission speed of the copper media? Are we using optical light sources? Those are all forms of bounded media, but what if we're using wireless, right? All of that's going to be defined down here at this lower layer. Some of the technologies that we have, again, things like copper versus fiber optics. IEEE 1394, this is the FireWire. We're using FireWire, if you will. And some of the base standards that we'll talk about all operate at this layer too. And again, we're going to tie up some of those loose ends later. But now just talk about bits. Bits going over some kind of connection media. And this is the area that it's defined at.
Yeah, this is ultimately where Wes goes out to his mailbox and he opens the box and there's actually something there, okay? That is the physical layer itself. He goes, hey, that's actually a letter from Ronnie, and then he can open it up and ultimately end up reading it. So, Wes, any last words as we kind of close out of this initial episode?
Most definitely, Ronnie. I'm going to give you a mnemonic that I want you to remember. All right? I know I'm going to give Ronnie a chance because I think he's got one too. All people seem to need data processing. If you can remember that, you can remember the layers of the OSI model. But that's not the one you use, right, Ronnie? What do you use?
I say that all people seem to need deep dish pizza.
I like your.
I know I have 2 D's in there, but it actually works for me.
I like food better. So
Yeah.
no, that's it. Just remember remember the layers and some of the tricks, if you will, to remembering those layers for the exam.
All right, well, that's a good place to end this episode, taking a look briefly at the OSI model, but there is more to come for the series, and I think Wes is going to also tell us about another networking model, so you want to stay tuned for that. Well, thank you again for joining us, but stay tuned for another Network Plus episode.
Thank you for watching IT Pro TV.